Thanks for tuning into this presentation. You're about to either watch a video or listen to audio recorded at the Grassroots Radio Conference in 2012 at the Independent Media Center in Urbana-Champaign. Please enjoy.
This is Henry Bell, who runs Southern Bell Electric, one of the local contractors on the project, and he's going to talk about what's happening here. I can hold this. Okay. I think you got to get real close to it. Louder.
What they're doing now is actually put five on.
No, we can't hear you. Okay, face this way so they can hear you.
That's worse than the Arby's drive-thru.
Yeah, face this way so they can hear you and talk right up into
Can you hear me in my normal voice?
Yeah.
Okay, my normal voice. Okay, they're sending fiber to the west. Okay. I got two 16-count fiber. They're going to blow with their machine. They feed it across the top of their pipe. And I got a guy down there that they're blowing it down there to them. I got to get all that fiber off the ground there. I'm blowing it to the west down there. So that's what I'm doing. I'm leaving a loop of it in each handhole so they can come back and splice it and take it a different direction in the future. So these handholes, these manholes, these quasi boxes, we leave a big loop of it in there so if some company in the future wants to come and run it this way, that way, there's enough left there. So that's what we're doing, legal enough, and we're blowing it at the same time. That's what I'm doing.
So what's that machine called?
This is fiber optic blower. He's blowing it right now. See him feed it in. He's blowing it right here. He's blowing it through this tube here. That way, down to my other guys down to the other end down there. I got two guys stationed down there that are pulling it out. They're only going to blow so much of it down this way, then they're going to stop and pull it up and put it in there. Then we're going to go down there and pull it up and put it in there. We started clear over at the main grill over here on Lincoln Avenue. You guys see that? There's a big spool over there. So we started with that. Some of these runs are miles long. This machine will blow the fiber miles and miles. We started with one run over here off of High Cross Road, the Walmart in Urbana, and blew it all the way to the courthouse. And you know how far that is.
You say you have 12
I blew it all the way to the courthouse. Huh?
This is 12 strands per orange tube?
No, that's got 216 strands fiber.
Right.
Okay, the biggest fiber I blew is 432 strands. Wow. I installed that. That's all.
How bad is that?
Oh, that's probably maybe outside OD outside diameter, probably almost 2 inches. That's how we measure it. It's electrical school or whatever. OD outside diameter. Okay, so that's the biggest fiber I run. This is a smaller count fiber. And what we're doing now, we've got the big stuff installed. What we're doing now is actually installing smaller counts of fiber. The local fiber, the MSTs for the neighborhoods, those are 12 count, 12 strand fiber in a neighborhood, 16 strand, 20 strand, down to like maybe an 8 strand piece. That's what we're doing. So in some of these neighborhoods, like on a local street, there'll just be a 12 strand fiber ran through all the quasi boxes, which connects to a larger fiber, a larger trunk fiber. That's how we connect.
I have a question. Hey, Henry. I live 3 blocks this way. So when I want to connect, is it that you're putting fiber here so that eventually we can run it over to my house and there's extra? Or is it that somebody else has to come open the manhole cover and put more fiber in to go to all these houses?
No, yeah. When we come out to do a house, because I'm doing the houses too.
Yeah.
Okay, we come out, we run one fiber from each home to the nearest quasi box. Then it goes from that box to the nearest connection. And at the end, we have end-of-line connections that are 12-port, 8-port, depending on the amount of houses on that street, okay? And your house is plugged into one port. That's how it is. And that one port, that one 12-port connection goes down to a main trunk. That's how we've done it. That's how the print's set up. That's how it was engineered, okay?
Where does the where is the connection to this?
They got fiber nodes. They have an Urbana node, they have a Champaign node, they have a UC2B node. Yeah, they have nodes.
All the rings go back to 3 data centers on campus. There's a state network called the Illinois Century Network, and then we use to get to Chicago and elsewhere.
We're doing another 50 feet to the box on the west of the street. He's already got 50 on the east, and we're sending 50 to the west, and then we'll send 50 to this wall. How much another 100 feet? And 50 feet all the way, and then 50 feet right across the street. And then leave like 50 or 80 here. That's what we're doing. So we got to leave a loop. We're leaving a loop in the box for future expansion.
And explain how, I mean, you started as an electrician. How did you get into this? How did you get a local minority electrical firm into fiber? And how have you been able to train people and get these jobs here in the community?
Well, first of all, I'm an electrician. I went to local 601. I was in the Army. Well, let me go back. I graduated high school. I got in the Army. I was an 82nd Airborne. I was actually a cook in the Army. Then from the Army, I got out and I worked for Time Warner Cable. I was one of the technicians. I got in as an installer. They kept sending me to Denver, Colorado for training. And I got a lot of training from cable TV. I worked for cable TV 4 years. I was a maintenance technician for the University of Illinois. Then I got in the electricians union back in '94, okay? Become a journeyman in '99, and I got certified through the state of Illinois as a minority contractor, disadvantaged business, IDOT contractor, okay? Then this project came up, and I was picked off the CMS list to be a minority contractor for this project. That's what that is. I'm actually on a registry that runs statewide. I get jobs, I get them over my laptop, they come on my email every day. 5 or 6 jobs to bid on statewide from everything. Because I have 2 companies now. I have Southern Bell Electric and HVAC, and I also have Southern Bell Landscaping and Maintenance. I've got 2 companies. So that's how I got involved with the project. I was on a CMS registry, a state minority listing, female listing, and that's what I was able to do.
Any other questions? Yeah, man.
Yeah, actually I wanted to know it's not even the last mile, it's like the last foot. What's the connection like inside the house? Does it just look like a Ethernet or what?
We will actually talk about that more at one of our other stops where we'll see. In this neighborhood, we're not doing service to every home because this wasn't grant eligible.
Got it.
But we'll spend some of our time on our next stops in the grant eligible neighborhoods.
Got it.
But explain that piece because you're involved in that piece of the project too.
It's gonna be an Ethernet cable. What they're gonna do is directly bury it to the house. They gotta sink a 3-foot ground rod to locate it. So if Julie comes out and you're planting a flower bed in the yard, we don't want nobody cutting it, so we can mark it with orange paint. Then up inside the house, there's going to be a box for an Ethernet connection inside the house. I think that don't quote me. I think they're connecting. My guys are connecting up to 4 devices in the house. Once they go to the house, once the work gets done inside the house, I'm not quite sure, but I think it's 4 devices that are going to be connected off of it. Am I right?
Yeah, there'll be a box in the house with like 4 Ethernet jacks.
Yeah.
1 strand of fiber that goes into the house to that box, and then from there you also get Wi-Fi and Ethernet and a phone line and other things that can branch off of it.
And you get a wireless connection as well.
How many miles does the fiber go without losing any RF signal?
Oh, wow.
Thousands, hundreds?
Yeah, we did a
Roughly.
Of copper and fiber 20 years ago for cable TV.
Right.
Simulated connect a run. There's
Long
no
way.
inside.
Long way.
Each ring's roughly about 15 to 17 miles each ring, but then you got to run all those laterals as well too. So it really adds up.
And with 400 strands around each ring, when you start multiplying it out, there's just tons of miles of fiber in the ground.
Right.
Yeah, but very little loss.
Right. Next to nothing. Right.
Okay, one last question before we hop on the bus. No? Okay, great.
Okay.
So if you want to look at the machinery really quick as we get ready to board, we have about 2 minutes to get on the bus and catch it to our next stop. Thank you so much, Henry. We are so excited to have you involved.
Thanks a lot.
Good luck. Give these guys a round of applause.
Thank you. Well, I'm going to do part of this little talk, and then Roger's going to do the rest. He's going to explain to you how this works. Basically, in the field, what we're going to have is this is your drop cable. This here will connect into the MSPs that are in the handholds out in front of the houses. That connector fits into that. Okay. So that's plugged in a handhole out in the field. Now, that runs from there to the house.
Here, let's let Nan get closer. Yeah, here too.
Oh, okay.
Mind if I
I'll come around here.
Yeah, Nan wants to
No,
peek
you want
in.
to close up this open?
See the guts of this machine.
I want to see. Yeah, come on.
Okay, there you go.
You get the front row view because you're sitting.
I know, but I can't. We got to get around the door here, so. Can you get me up on the side when you're gone?
All right.
All right, good. Okay.
So this will be plugged into the field. It will run up to the house.
Ooh, all right. It looks like a phone box.
This part here will go through the wall into this box. This box will be mounted inside the house. This is the LNT in the router. All they'll do is they'll go in and set this in the house. They'll take the fiber jumper. They will put the fiber jumper into that box. And if we've done everything right in the field, it'll have light.
At that point, is the Wi-Fi router, the 802, is that slower than fiber?
Roger.
That would slow it down.
Roger's my equipment guy.
Well, the Wi-Fi will run up to its capabilities.
Yeah.
So it'll give you whatever speed you have.
Okay.
Okay, I got it. I'll take it. Anyway, right now around town, we've got 12 of these cabinets that were grant funded. So this one here happens to be the cabinet number 11, but they're not really in order like you would think. Each one of these cabinets have 576 fibers come into it. I'll pull this apart here in just a second to show you the splice. So there's 576 fibers that are spliced from here through 2 cables into these panels. These are your fiber panels. Roger's going to take it as soon as I get done with my little spiel here in a minute. We'll jump out of these fiber panels. It'll go over to the electronics, which will be Roger. But we've built, when we get done, we'll have over 300, a little over 300 mile of fiber. That's springs, laterals, to feed the home and drops to the home. We'll have just a little over 300 miles. I do this slide. The MSTs, which we can show you, I'm not really ready. They'll be up to Brandon if you want to see one. They're down in a handful down the block here. The MSTs, which is what this plugs into in the field.
What's an MST?
Multiple subscriber terminal.
Okay. Thanks.
Sorry about that. So in Urbana, we've got about 200 of those right now. Well, actually over 200 of them. Around these neighborhoods, all the neighborhoods. Usually what you have, you'll go down the block, you'll hit an MST. It drops and feed back out of that. The MSTs are 4s, 6s, 8s, and 12s. So you can feed up to 12 homes off of one MST. Those MSTs go back on the lateral cable, come back to this box, and go in and get in on there. That's where we make our connects. We've been working on this project for a little over 3 years. We got about 340 splice cases we have to do put in the field to get all the ends put together and everything tied in. We're about 40% complete with that at the moment. But they're splicing every day and they're picking up the pace. We have 3 splicers right now working on the project all the time. So that will get those done pretty quick. As anything else, the only drawback to the holdup right now to firing this cabinet up, because you notice there aren't any pretty lights blinking in there. If you look at that telephone pole over there, you see 2 gray pipes. That's the power feed from Amherst. And of course it comes here and will be a power meter.
It'll be actually powering the switch, so we won't run directly off the AC power, so we'll be immune to that. Plus we'll have a battery bank below that will also be a backup for the DC power plant. If we do lose power, or if there are glitches or static in the power, it'll be filtered out. If we get a power outage, it'll run on the DC for 7 hours, an hour.
Just off the battery.
Usually if there's a total outage, it'll affect the whole neighborhood. But if we do need, we could even fall back to a generator for a long-term outage.
We have generator plugs on each one of these right there.
So you can drive up and plug in a generator.
Drive up. It would take coordination to do it. Usually, but if say you had a home and you had a small UPS and you did have a power outage, this will work for a limited amount of time until your UPS probably runs down.
Yeah, it won't go down. we're waiting on that. Everybody in the country right now is trying to buy fiber, so it's slowed fiber deliveries down. We're waiting on a 12-count fiber to come in. Should be in here in another week or so. Then the whole pace will pick up and we'll get started again. Basically, 99.9% of all the duct, the orange plastic duct, is in the ground in Champaign, in Urbana, Savoy, and at the university. So that's all done. We have fiber pulled in probably somewhere around 75% of it actually. The fiber is in place. Then we got the splicings coming up behind it. But we have not done any drops because we're just getting these in this week. And unfortunately, until this cabinet is fired up, we can't go out and do drops and hook up houses. Because, I mean, you know, you don't want to go hook up your customer and tell them it doesn't work.
But this is the eligible neighborhood, so, you know, there's enough plugs in here for all the homes you see.
Yeah, all the homes here, this one here, I believe we're feeding right close to 480 homes out of it.
Just under the 500.
Yeah, just under the 500. These houses are ready to go. I mean, the minute the power company comes here and they put that up the pole and get us AC power, Mr. Kelso over there, the other one, and he's going to give you another talk here after a while, is going to be in here installing these houses, and at that point all the customers will come up. We'll just walk through them and light them up.
Have the folks in the neighborhood signed the form saying, yes, I want fiber, and we know, so it's just a matter of installation?
We were up to about 900 by last week's count.
Awesome.
Yeah. So we got the addresses.
We got about 3 minutes here on this stop before we're going to go see fiber splicing. I want you to open up this thing and explain what we're looking at.
Well, we're opening that. We'll open up the back of this and you'll be able to see where the fiber from underground actually comes in. I just didn't want to open it and get too much traffic here. These
are you blocking traffic, Kevin? Is that what you're doing?
I'll be the corker.
Like this. Keep those cars out.
Now these are actually the 576 strands that come through this underground that go in different directions around and are spliced off to the homes. This is sort of the backside, and you'll see them. Every one of these ribbons has 12 strands of fiber, and it's spliced through to the connectors we saw out front. If you want to look at the connectors again, and that gives the entire circuit. And then from the connectors, they go over to the switch gear, which was on this side, the Adtran switch gear. Each residence will have a port on that switch, which will provide their connection.
Basically,
we'll provision that port to the speed, the 20 meg, 30 meg, 40 meg, whatever they subscribe to. And then those ports will all get together, and then it'll go into a ring that connects all the pedestals back to our central network hub.
So all these people are in from out of town, and some townies. Curious how this works. Briefly, this company is Volo. They started out as an internet service provider doing Wi-Fi here in Champaign-Urbana. They're a great locally owned company, and they ended up, for their own business, starting to run fiber, learning how to do it, and then all of a sudden got a subcontract to help build this community on fiber optic backbone. So Jesse is prepping this cable, and Jesse, you want to really briefly tell us what you're doing here and how this part of the job works for you?
My part of the job is just getting it ready for splicing, the actual connecting the wires to the front of the house. I'm just getting it to bare fiber, and Sheila, our other worker, does the splicing. Basically what I'm doing is stripping back all that cable and getting it to bare, putting it in the enclosure. Winding it up nice so she can actually work with it.
Great. And we might get to stop and see Sheila down the street as well and see her actually do the splicing. Okay, he said white and right, so we'll see on either one. Any questions for Jesse about this piece of the process and about how he got involved?
So how many layers is it that you have to strip off?
3 layers.
We got this black layer, green layer.
Shielding, and then the actual tube.
Yeah, you might look.
Okay, so what does the actual tube look like?
This is what the tube. This is the tubing.
Oh, right.
Oh, I see.
Oh, yeah.
It's
so
pretty
these are,
strong.
So how many fibers
12?
are inside of there? 12?
This is a 24
24.
count. And then the other one, well, this is actually 216. That's the 24 count. This is the 216.
So that's the kind of the bigger sort of
Yeah,
master.
432 is the biggest I've seen.
So these are cables that are connecting up to cabinets or to a group of homes, or do you know which one this is?
I believe this one goes to homes, but I could be wrong.
Down there I also see a 432, so that must be more of a one of the ones between cabinets. Between nodes.
And does everybody else already know who Volo is? I don't.
Yeah, Volo Broadband is a local ISP. They're locally owned. They started as a Wi-Fi company, putting up antennas and blasting Wi-Fi out into neighborhoods and just offering good service that doesn't have data caps and good like net neutrality kind of policies. And then they started building fiber and ended up getting a subcontract to build a bunch of this fiber optic backbone and be part of connecting.
They're also a co-sponsor of the Grassroots Radio Conference and big supporters of the IMC. We love Volo.
So when somebody gets their bill at the end of the month, is it going to come from Volo or is it going to come from UC2B?
It could be both. So at first people are signing up just for basic internet service from UC2B, but Volo and a number of the other local and regional providers, because it's open access, the whole idea is the public sector owns the infrastructure, owns these wires in the ground, but lets any private provider use them and compete over them to provide you service. So the theory is more the European or Asian model, that with shared public infrastructure, you get a choice of providers that means more competition, cheaper prices, better service, and you're never locked into like one monopoly provider who just owns the cable to your house.
Mm-hmm. But the public can run, like for example, there's a group of us talking about doing a co-op ISP as a potential non-profit provision that would be able to provide service and then take surplus and reinvest it via grants in the community. It's also the case, I'm sure Brandon said this on the panel, but it's worth saying that there's also a percentage of the funds that comes in that goes back out and is reinvested in digital inclusion initiatives. I think that's a really important piece of this picture.
Yeah, absolutely. One last question while we're here. Okay, let's hop aboard our bus. And, here's Peter. So Peter Falk is actually the guy who runs Volo Broadband, and we've just heard a bit about what this is and how this is happening, what Jesse's doing here to prep these cables, and we saw the cabinet around the street. But I mean, I guess tell us, for you as a local company, we already described how cool Volo is and wireless and all that, and how you got into this. But tell us what kind of community impact this is, like how you've been able to train people or employ local people, what the impact is for a local company to be part of this project and to make an impact here in the community.
Sure. So we're normally a service provider. For the last 10 years, we've been the people who provide and charge you monthly. We kind of reoriented ourselves into a little bit of a contractor and a little bit of an economic development organization here. The people you saw blowing cable are actually our bosses. Southern, we work with Southern Bell to help them gain the fiber expertise to do this kind of work, and we train their people on how to do it, and we to some extent help them handle the logistics of it. So with this project, we were able to get, I think at the peak we had 14 people in 2 shifts putting fiber into the ground, and I don't know, I don't remember what questions you asked, but it's exciting and fun to do, and I'm especially excited about some of the people who are working on this project. This is the most they've ever made, and we hope that if we can continue this project going citywide, they'll be doing it for quite a few years, and then we'll branch out to moving to normal or something like that. So,
awesome. Public infrastructure and a living wage.
Yeah, exactly. 3 cheers for Volo in that.
You saw the individual strands of fiber going into the little clear plastic splice protectors. The splicing is one of the most amazing things that I've seen, and even more amazing is that it's not actually a skilled job anymore. I mean, it's moderately skilled, but you can teach anybody to do it in a couple hours, and they'll be reasonably good at it. Basically, what the machine does is you take 12 strands of fiber and you cut them all off at exactly the same length, and you fit them into the machine in these grooves that hold them in exactly the right position, both up, down, and left to right. Then, so the machine has your two 12-strand ribbons in it, and it moves them around and gets them so that they're, well, on the screen it looks about like this, but remember each of those strands is about the size of a human hair. So it's 12 single human hairs all lined up to within about a micron of each other. And then you see a bright light, there's an arc, an electric arc inside the machine, and when the light's gone, they're fused together like somebody doing glass blowing. And I don't know if Brandon described to you what fiber is, but fiber is actually, that human hair size strand is actually the outer coating of the real fiber, which is at the core of that. The fiber is two different types of glass, one layered inside the other. So one of them is about 0.125 millimeters, and the other is about 0.09 millimeters. So when you fuse them together, it has to keep those two types of glass so that you're only fusing one type of glass to itself, and then the outer glass is fusing to itself. So it's really a pretty amazing operation. Not honestly much to look at because it's all inside a little box, and you wouldn't be able to see the visuals. But the tolerances that we're able to do really without that much effort are kind of are shocking.
How much does the equipment cost?
So what I should be doing right now is writing a paper for a conference, and it's entitled "Fiber to the Home on a Shoestring." The basic idea is that you can spend a whole ton of money on the equipment, on the materials, but if you keep your eyes out, you can actually find it for relatively little. One of our splicers that we bought for this job, because we only had one ribbon splicer before and we wanted two, was $2,500. So it's money. It's not something that you buy without any reason, but it's not that much money. It's something that any organization can find the funds for. That you then have to have them recertified by the factory to make sure that they're in compliance with everything. But they're available, and it goes up from there. Probably minimum price for a single strand splicer is about there, and the maximum price you would pay for any splicer in a normal situation would be about $40,000. There's one other tool that is super neat in the fiber world that you don't see much else or anywhere else. It's called an OTDR, stands for Optical Time Domain Reflectometry. What it does, it's a tester, and it's probably even more than the splicer normally. I think the cheapest one we got was kind of a mini handheld, not very complete one, and I think it was $1,500. We've also paid, I think, as much as about $11,000 for it. What it does is, talk fast, it sends a pulse of light down the fiber and then watches for reflections. And a reflection could happen if there's a break in the fiber or if there's a bend that's too tight. And based on when those reflections come back, it knows how far it is away. It shows you a map of how either the fiber passes the spec or it has a problem at a certain distance. You can then roll out that distance with a wheel or know where the foot marking is and find your problem. So it's another cool.
Cool. Thank you so much. One more round of applause. So I want to introduce you all to Chris Kelso. Chris is with Power Up Electrical Contractors from St. Louis, so they're here from the region. They're a minority contractor, a subcontractor on the second phase of this project. Here they're actually hooking up an anchor institution. There are 200 or more, and they were on the back of that map that we passed around the bus. So Chris is going to tell us what this is, what you're looking at, and how this work gets done. Chris?
Yep. Okay, well, again, my name is Chris Kelso, and I am the Datacom Division Manager for Power Up Electrical Contractors. We're a minority contractor based out of St. Louis, Missouri. We are a minority contractor, and we've contracted with other minority contractors locally, one being Southern Valley Electrical, to perform some of the residential installations. As of yet, we have not begun to do the residential installation, so unfortunately we don't have one of those to show, but we do have a fairly standard commercial installation. And what I'll do is I'll talk about how we get from the curb to the premise, which will be the building or the structure, and the different ways that we do that. and the different modes of getting that cable from there. And I think everybody's seen the splice boxes so far, the MSTs, and I've also got the equipment that you saw earlier. And I think someone had a question about the speed of the router.
Right.
I did some checking on that particular router, and that should be the one that everybody, all the residents, is going to receive. It'll go to speeds up to 300 megabytes per second. So your typical standard low router that you buy at Best Buy or someplace like that will be anywhere from 100 to 150. So you're getting considerably more megabytes out of that than you would out of your low end ones that you'd buy yourself.
So yeah, tell us so in the home though, if they wanted faster speeds than that, they could hardwire into their home router.
Well, you wouldn't hardwire.
Not hardwire,
basically,
but sorry,
what you would do if you wanted
get a
faster
Ethernet or
speeds,
something.
all you would
different
have
router.
to do is replace this router.
I was going to say get a better router.
I actually have one in my vehicle that I was going to use as to show the difference between the two. But since this one is so fast, I didn't feel the need to bring it out. But
the optical part, the bottom box,
the bottom box is gigabit.
Yes.
This is your route or your modem. This is basically, if anybody's a customer of Comcast right now, it's what's going to be interpreting your fiber signal.
So this is that strand of fiber that comes in. This
Correct.
one talks gigabit.
Because a lot of these folks they care about it kind of media uploads.
Yes. Yeah. Now your upload speeds or your download speeds, which information you be pulling off the web, those are going to be considerably faster, generally speaking, than your upload speeds. Your upload speeds are generally going to be decided by your equipment, not the internet speed. But if you decided to replace any of the equipment, this would be the piece that you'd want to replace. And I'm not sure if it does go VG&N, so it's pretty much capable of all the wireless technology that's out there right now. So it is relatively fast. But let's talk a little bit about how we get from the curb to the premise. This one is a good example of a worst case scenario. Because it was so short from the curb to the premise, our underground crews dug out the trench, laid the HDPE conduit in the ground, and then covered it up. So this would be the worst that you'd ever expect to see. Typically, for a longer run, let's say for instance if that handhole were at the corner, our underground crews would have directionally bored, which it's a machine roughly about the size of a Volkswagen Beetle. It has 10-foot sticks that it pushes into the ground. At the very tip of that first piece is a piece that looks like a spoon, and they can direct it one way or the other to go deeper, side to side, or up. So whenever they finally get to this portion, they turn that spoon up and it comes up out of the ground. Typically, if they're going to use that method, you're going to have about this much excavation at the premise and approximately that much excavation at the handhole. Now for residential, this wouldn't be a typical installation. You're going to have this board over here that they would use a machine called a vibratory cloud. Basically, it's a little bit bigger than a garden tiller, and it's got a blade that vibrates into the ground, and it more or less drags this through the dirt until they get to the premise, and then they'll have a small excavation and then bring it up into your home. And we can do that by a couple different methods. We can do a subgrade penetration if you have if you're on a crawl space and we're going to an interior wall. We can penetrate that footing below grade, take it into the crawl space, and then route it to your home in that respect. If it's a finished basement or an unfinished basement, we typically wouldn't do that because we don't want water going into your home. But so so there are a lot of different methodologies in doing that, and we could go into them if anybody has questions about them. Any questions? Anyone?
Questions?
So what do we got here?
This is called an LV. It's a conduit body, and that will transition going from horizontal to a vertical. You can use a few different types of methods in doing this. This is probably the most aesthetically pleasing. The other method would be to mount a big box here, and with this being a busy street and it really impacting the looks of the side of the building, that's something that we decided not to go with, along with the engineers. Rather than have this big obtrusive box on the side of the building, we go with that. It's a little bit cleaner look.
And it goes inside.
And then it goes through the wall, and then we'll transition into a duct. And this is an underground duct. What we're using inside is a corrugated duct. It's a lot more flexible than what you would have underground. Where this is extremely rigid, and if you try and bend it by hand, it'll collapse. Where the duct that we use inside is very flexible, but it's also very protective of the fiber that's encased inside.
For running Squigglier with that machine you're talking about, the Volkswagen Beetle digger, the conduit for that, it's not straight, so is that expensive conduit, or how do you, is that
It's not extremely expensive, but it's very, very durable. I wish I had brought a sample of it. The outer casing on it is anywhere between 3/16 to a quarter of an inch.
but it's not hard, it's soft, some kind of malleable to get through?
It is flexible, yes. It's, when I say rigid, I'm just meaning that the outside diameter of it isn't easily crushed. But it is flexible in its lengthwise form. It's flexible one way or the other. But the diameter of it, if you look at a cross section of it, it's not going to be very easily crushed at all. So if you go underneath a high traffic area, you're still going to want to be below 24 inches below grade. But you still don't have to worry about compaction around it.
Do you have to worry about vandalism?
With something like this?
Yeah. Sorry.
That's a good question. You do, and that's one of the reasons here why we chose to transition to an EMT rather than the PVC. Just because it is a little bit more protective. Now, if you have a vehicle that runs up against it, obviously it's going to crush. If we had done rigid there, but this isn't a high traffic area or something like that. If this were a parking lot and this were a parking stall directly in front of it, what you're going to typically see are ballards or posts sticking up in front of it, and that's going to help in anything like that. But as far as vandalism, there's really no intrinsic value to the fiber optic cable by itself. So unlike copper cable, which everybody and their brother wants to take and scrap, there's really no value to a piece of fiber at all. So I think the worry about vandalism from theft I think is pretty low. Vandalism, just vandalize. If they want to hurt it, they can. But it'll take quite a bit of doing. Question?
Is there any reason to ground anything at the house location?
You know what? Great question. I'm glad you brought that up. It's not grounding.
Okay.
It's a trace wire. And what you see here is a ground rod. They'll typically be about 3 foot, and it's not grounding in any shape, form, or fashion. It's solely for tracing only. And you'll get that at every location, regardless of whether it's a commercial location or whether it's residential. And if you look on this cable, you'll see this little bitty wire here. And before, this wire will never enter a premise, a structure, residential or commercial. What we'll end up doing is taking it out of this LB and then bringing it down and tying it to that ground rod. And that's solely for a point for the locators. Whenever they come out to locate this utility, they can induce a tone onto that and trace it out where it runs.
So, in the open access model, one of the partners, somebody has to be the infrastructure owner. And in the existing UC2B network, because it's open access, the infrastructure owner is the municipalities, the 2 cities and the university. And then we hire, with open competitive bidding, hire a private company to be responsible for the maintenance of that publicly owned fiber. And every few years we'll put it out to bid again, and maybe a different company will win in a few years. But there has to be one entity that really owns it and is responsible to keep it maintained. And we are even own the boxes, those boxes that go into people's homes. Those are owned by the municipalities, by the city. So if your box breaks, you send a truck out, we have them fix your box and give you a new one, and take the other one back and try to get it repaired. And even those boxes are the responsibility of us as the infrastructure piece of that open access puzzle. And then all the private providers like Volo that might sell you internet service over that, or TV or phone, they rely on our infrastructure, but they really provide you the service and send you your monthly bill. When the infrastructure itself is broken, they call us to repair it, and we send out the repair crew. So it's an interesting separation there between the infrastructure provider at that layer and then the numerous private providers that on top of that can compete to sell you service and give you choice.
Well, really, it's just like dial-up when you think about it. You had the infrastructure, which was the phone lines, and you had your different service providers like AOL, Urbana.
You could choose to call into any of them.
Yeah, exactly. Yeah, it's a similar model. Yeah, it's how it should be.
People also described it as just like the roads and the bridges. The public owns the roads and built the roads and maintains the roads, but private commerce, community, any interaction can happen on the roads. Any company can deliver their goods, or any family can go buy a car and drive their kid to soccer practice or to art class. The public will use the roads in any way they want, but it's a shared community piece of infrastructure that enables us to connect to each other.
And so the end service providers, how do they then connect with you? I mean, are they leasing? How are they connecting you?
Right. So they call us up and they say, hey, I want to hook up this home with phone service or TV service, and we make sure that house has a working box, and that the house has a drop, a connection into the home. And if they don't, we build it and get them the box and turn on the box. And then, as Peter was describing, we have a cost of $17 per home or per acre. It's our wholesale price, meaning it costs us $17 to keep that fiber, the neighborhood cabinet, with all the lights and the batteries, and the folks who drive out in trucks and repair it. It costs us $17 to keep all of that infrastructure in place. And so Peter, as a private service provider, has to work that $17 into his monthly cost to pay back to us, for us to keep the infrastructure maintained and replaced over time. And then Peter can charge, whatever he wants, and offer whatever services he wants, gigabit, whatever it is, TV channels and ESPN, the sky's the limit.
You've been watching or listening to a presentation recorded at the Grassroots Radio Conference 2012 at the Indie Media Center in Urbana-Champaign. Thanks.